Hi, my name is Jeff Dalgleish, and today I'm going to take you on a walkthrough of two use cases that we built with our platform, Review. The first will be a well review application for the oil and gas industry, and the second will be a defense application for cybersecurity. We're going to do a pretty big deep dive into all of the tooling and capabilities we have as a platform. You'll see how we can use artificial intelligence to reason over private data. This can be done in a public way using open source models or in a private way running on hardware where the large language model is running locally. So let's start with the well review and then we'll jump into cyber review. So the first thing about the well review application, you'll see the first four tabs have the suffix AI on the end. So what that means is every one of these tabs, no matter what line you're looking at, you can double click on it and it'll take that piece of information, it'll summarize it for you. But it's going to summarize it from a particular perspective. So right now I've got it summarizing that from a drilling engineering perspective. And you can see on that main screen I've got this reasoner perspective. So if you change that to a different perspective, it's going to change how it's summarizing the well. So in this first case, we're looking at this Boone Coffee well from a drilling engineering perspective. And it gives you basic well information, well construction, completion, stimulation. So a lot of detail that would probably be interesting to a drilling engineer. It comes in with recommendation, engineering analysis, and observations. So quite a bit of detailed technical information. Let's try that exact same well. We're going to switch it to an accountant and double click on it. It'll take about 30 seconds to run all of it. Oh, that was a bit faster. But this is just from an accounting perspective. So one of the things is all these entities we have in the system have so much information in there. It depends which perspective you're looking at it from. So if you're a drilling engineer, you're going to want to see all the technical oil and gas data. But if you're an accountant, you're probably going to care less about that. And you'll be more interested in like production information, economic production, how efficient is this well, what are the financial considerations. So it really changes sort of how the AI is behaving. And again, you can pick any one of these. Let's say a regulator would be another example. Maybe you're going to demo to a regulator. So here it's the same data, but now we're looking at the well, and we're probably going to get classification, construction depths. So these are all regulated things, how deep the well goes and where the perforations are and how they're doing the hydraulic fracturing. All this information is stuff the regulators care about. So it looks like there's a lot of interesting information here that you can take a look at from a regulation perspective. But all that's being driven from the same place. And that sense of changing this perspective is going to work on regardless of what tab we're on. So if we go to the well SWD AI, this is, again, it's well information, so it's really the same wells, but instead of just the performance information, now we're looking at like some of this SWD information, like dates when they're going to start it. This is information that we're going to need to know about these wells for an SWD's perspective. But again, you can double click on any one and it'll basically come back with a summary of it. It's different than the other summary because this is a different set of information we're looking at here. Here we're really just looking at the SWD data. So I'll just close that. That's the same for this SWD AI scorecard and same for the DNC schedule. You can double click on them. One thing to note, these tabs up here, if you scroll to the right, you'll notice there's more of them. So for example, the photographic evidence that we have in here, this takes a second to load just because we're really just showing the PDF file that we're ingesting. It's a fairly large one, so it might take a few seconds. There we go. And if you just scroll down, you can see it. You can zoom in and out, the usual things. But this is just if you care to show it. I'll just go back to the cyber review demo now, because the rest of the stuff has stayed the same. There's still a well reasoner here. If you click on the well reasoner, this really runs our main reasoning platform. You can ask a question about anything. You can look at like anything about the whole data set. So this is really where to get started. I'll go back here. There's a document reasoner. Earlier I asked the questions, what are the terms of the lease? And it shows there's a couple leases loaded in here. So it really just goes in and extracts information from these documents in terms of the fees, the production, all that kind of stuff. Okay, let's switch gears. Let's go take a look at cyber review. First, a little bit about what you're going to see today. There are essentially 6 modules installed on the Dell hardware. The first is the structured data loader, which takes care of loading all the structured data from CSV files into our knowledge graph. The second module is the unstructured data loader. This takes unstructured documents and loads them into the knowledge graph. It'll extract entities from the structured and unstructured data as well. The time series data loader, this is used for loading high frequency time series data like server logs. There's a graph reasoner, a graph rag reasoner that we have installed on the box that we built. This is a big part of what we do. Our graph reasoner is unique in the sense that it allows people to reason over subsets of graphs. We have a graph explorer for looking at the graphs and interacting with them. And then we loaded a data set onto the machine, which is the CyberGenok scenario, which is really a scenario. We'll dig into it in a second, but it's a use case essentially. A bit about the hardware. We've got components installed on the machine that underlie our software. So we have our API on there for running the modules. We have Retool as a front end. Neo4j is a knowledge graph. We're using the Enterprise Edition. We have XQ to protect moving information to and from the hardware. We're installing Llama on the hardware so we can run a local language model. Right now this machine's connecting to Claude 3.5 or OpenAI ChatGPT-4. We can connect to any type of large language model to power the reasoner. And then we use Milvus for a vector store. And we'll take a look at two of the components today, really the user interface that's running on it, and then a graph explorer that's also on there. So what is Cyber Review? It's a strategic defense tool that integrates human intelligence with cyber intelligence. So we're going to go through a scenario today which basically is a human intelligence story where we find a piece of intelligence and we want to understand how that intelligence relates to everything else we know about our infrastructure and other things that are happening in the region. And if we can figure this out, we can stop a cyber attack. We want to be able to find not just which machines were infected, but other machines that might also be infected as well. So I'll show you how we do that. The data set, a little bit about that. Part of the data set came from Professor Ed Waltz at Patrick Henry College. This is for a strategic targeting class that he teaches there. And it's a fictional scenario, none of it's real, and this is all fictional information is used to train students at strategic intelligence. We added to the data set an additional data set. So the initial one was this Genok scenario, and this is really just a bunch of information about the killing of a U.S. asset in Afghanistan. And the subsequent story on top of that, we added Cyber Review, which basically overlays a cyber attack on top of that scenario. And this is really what we're going to use the tool for today. There's a piece of evidence we found. Again, this is fictitious, but it's an interview with Hamad Darzi. We received a note on Darzi's computer from a hacker located at an IP address indicating that a server located at another IP address is now listening to, and then a malware endpoint, and it's controlling the controller and awaiting your instructions. So this is information we found during an interview. We were able to retrieve this information. We want to see, what does this information mean to everything else that's happening? So the question we're going to ask the AI is, what is the significance of the human intelligence evidence that we got off Hamad Darzi when we interviewed him about the death of Genok? I want you to tell me about what systems might be infected and what we should do to patch them. So let me show you how Cyber Review handles these types of questions and answers. So the application itself is here. Let me just give you a sense of what data is in it, and then we'll jump into asking the question. So Cyber Review has some reasoner settings. We won't go into these in the overview. We'll kind of look more at this information. So we've got human intelligence here. This is showing all of that intelligence, like this note that we just found here is located here, and there's a whole bunch of other intelligence that may or may not be related to this. So for example, there's a lot of information. All this information together is going to form a knowledge graph. There's also a bunch of financial intelligence, so a bunch of bank transfers we have in the system that from one account to another. We've got signals intelligence information, which phone number called another one. We also have a list of critical servers in the system. So if you double click on a particular server here, what we do is we're going to use generative AI to automatically summarize that server and any implications of what that server may be connected to. So it'll take a minute here. I'll keep explaining what's going on while that's running. We also have DMZ servers. So a similar screen to the critical servers, but these are servers sitting in the DMZ. And then we've got a dictionary of malware endpoints. This could be something that's obtained early. Oh, the answer came back here. So what this is saying, it's basically looking at this server and it's able to identify it's a top secret server, and we're reasoning right now from a top secret level. So this is we're seeing access to all information. You can change that to drop the level, but it looks like it's able to come in with basically a summary of what's on the machine. It appears there are some suspicious connections between this critical server and a DMZ server. So this is outlining a DMZ server. 1.61.80.33. Later, we're going to see this server. This was a server that was actually found on that piece of evidence. So by clicking on this one, it already knows that this server is connected to something that looks suspicious, and it highlights it. It also says that this DMZ server was observed to connecting to a malware endpoint. So it does connect that malware endpoint that we saw in there. So it summarizes it, and it basically knows what this server is and what it's doing. So that's interesting. We'll go to the DMZ servers. So this is those same servers, but this is just your list of servers here. There's malware endpoints. Again, this would be a dictionary of what malware endpoints are out there and what's the summary of them. What's the vulnerability? We use the CVE descriptions because we can connect and have the reason over CVE information, the description of what it is, and then just some additional information about that particular malware endpoint, when it was seen first, what threat campaign it's part of, so usual malware tracking information. We've got internal firewall logs, external firewall logs, and that's really the universe of data that we have. So we want to ask that question. If we just go back to what that question was, what's the significance of this information? So let's try it. Let's hop over to the user interface. We're going to go to the reasoner first. And when you're demoing this, I think the last time you come to the screen, it will leave whatever you had on the screen last time. So I just asked that question earlier, what is the significance of human intelligence? So after asking, it comes back. It looks at Darzi. It identifies that he's a financer of coded operations. So it's able to recognize what bank accounts are connected to this individual in different pieces of intelligence in the graph. It does a technical evaluation from the interview. It looks at, there was a note found, this is a note we know about already. But then it's looking at these systems. So it's seeing that DMZ server, 1.61.80.33, it's looking that up. It's recognizing that that's also connecting to two other servers. There's this one 7676 and this one 61.180. These are two different servers that are connected to that same DMZ server that's talking to the malware endpoint. Even though the note we found only was talking about this one, the graph recognized there was additional connections to that server from this other one. So this server could be compromised as well. So what are the recommended patch? So it looks at first the one that it noticed first, and it comes up and then it looks at all the technical information we have about the server. We can bring it together and figure out what type of patching strategy or what information we have about that server that we potentially could patch it if it's in the system. It can look at how to do long-term remediation and limitations. So some of this information might be really useful. Some might be pretty obvious as well, like being able, like system hardening, for example. There's lots of steps that it'll put in there, but it kind of gives you an idea based on a question what's going on. You can ask it any kind of question, like let's say you don't know who Hamad Darzi is, so you could say who is, or describe who is Hamad Darzi. So it'll run. This will take a few seconds to come back with an answer. But it's basically going to take all the information in the graph related to this individual, and it's going to bring it together into a question, and it's going to pass that to a language model and reason over just that subset of the information that is connected in some way to Hamad Darzi, which is the person here that's this piece of information was found on. So being able to come up to speed very quickly on these different types of individuals or different types of servers is really what these systems really help with. Let's just go up here. So here's an analysis of Hamad Darzi in the Janok human intelligence evidence. It's looking and it's noticing that Hamad Darzi was identified as finance through numerous operations. Then it quotes a node here, 154. And then it's looking at he utilized bank accounts from the certain bank, and there's some bank accounts here. So it's connected that financial intelligence with the person. It talks about some locations where he's been seen. It looks into Janok, intelligence gathering, and then the death of Janok. There's different nodes here in the graph where it's noticing that Darzi's located near the vicinity of Janok in different instances. And then it looks at the infected system. So it's connected together a whole bunch of information here. It connected together banking intelligence, cyber intelligence, and human intelligence. And then it comes up with some recommended actions for what to do about that server that got infected, just by asking about Hamad Darzi. So there's some very interesting answers. So getting into this, how do you bring the reasoning power of an AI to bear on these large, complex knowledge graphs? And let me just show you what the knowledge graph looks like, just to give you a sense of the complexity of it. I'm going to open this up in what we call our Graph Explorer. And our Graph Explorer is a tool that is sort of a high-level view of how all of this information is connected to itself. So in this example here, I'm looking at I'm just going to bring this up into another screen to kind of get a little bit more room here. I'm going to open this. And what that will do is it'll connect you to that back-end graph where all of this information is living, and then we're asking questions over it. So this is what we call evidence review. And in the first tab here, if I just zoom in a little bit, we've got a knowledge graph here that is looking at all the human intelligence in the system, the cyber intelligence in the system. It's bringing in all the people it knows about, what servers it knows about, and what tools it knows about, and how all that's connected to itself. I'm going to add to this picture the financial intelligence because we want to be able to see what banks potentially are in here. So it's going to become a more complex graph, but let's just zoom into it and see what we can learn from looking at this graph structure. So I'm just going to zoom in a little bit and find a couple of nodes. So here's Hamad Darzi. This is the person we were just looking up. So if I double click on him, it's just a node in the graph. It's got who he is, and we notice this is secret information. So when we're reasoning, all these nodes in the graph can have a different level of security clearance so that we can filter things out if we need to. So let's just take a look at some of this evidence here that we have. So if I double click on this one, I'm just going to click show. It says highly reliable source Janok has verified with medium confidence that Hamad Darzi is financing a large number of coast operations using an intermediate Jamal Saab to transfer funds. And then it goes on to list those 2 bank accounts, which the reasoner picked up on, that we need to look into. So let's find out a little bit more about those bank accounts. If we close this, we can see this piece of evidence we were just looking at here. We can see what other entities are connected to it. So for example, we've got Jamal Saab being mentioned, we've got Janok being mentioned. Let's put in, we don't have the bank accounts in here, so let's add those. We'll add the bank. It's going to get a lot more complex very quickly here. But let's see if we can see those bank accounts. I have to zoom in again. So zooming in is just with your mouse. You can zoom in and out. If you click and drag, you can move the graph around. So let's say here we're looking for Darzi. And we go here. So here is that intelligence, and you can see now we have that bank account showing up. And we can keep going in this graph. I won't go into too much detail, but these are the bank accounts. We can go to these bank accounts themselves, and we can actually zoom into them. We can drill into them. We can expand them and go and see what other things are these bank accounts connected to. Like this one, for example, is connected to 14 other transfers. So this bank account these are all these different transfers from other bank accounts to this one. And we can start following these transactions all the way around. But the neat thing is the reasoner can actually do this as well. But it's an AI following the graph and moving through it and looking for connections between things. So this is what entity review or evidence review does. It's really how do we want to look at the evidence as a graph. A simpler way might just say entity review. Let's just say we're interested in banks. We can click on this and we can basically get a quick view of all the different banking transactions that have gone on and how they connect to each other. So maybe this one over here is a very boring, like one person transfers to another, but this was maybe a more complex web of transactions where maybe it's people working in conjunction with one another to launder money or to finance the killing of somebody. In the case of this use case, that's what it was. Person review, you could go and put a person in. This is Hamad Darzi again, and now we're looking at all the information we have about Hamad Darzi. So we've got Darzi, we understand where he's coming from, what bank accounts he's connected to. So what do we know about an individual? This is really just a quick way of summarizing that. We've also got a concept review, which is instead of like let's say kill, let's show me all of the content in the system that's related to somebody or being talked about where there's being killed or attacking. So you have different graphs for different concepts, how and who is talking about a particular concept, and then we can lay that out on a map to understand where they're talking about it. Last thing here is really just our knowledge graph itself. So we've got an evidence-based, so we have a knowledge model that runs this whole thing, which really keeps track of all of the different types of entities and evidence that we have in the system and how we classify everything. This is really the type of information we're reasoning over. And then we have a summary of how many pieces of intelligence we're actually looking at here. So it's a quick summary of all the information we have in the system. That's what the Graph Explorer does. Now there's something really cool with this. Now whenever you click on any one of these lines, each one of these pieces of information here are just little snippets of intelligence. So this first one here, if you click on it, interview with Hamad Darzi, note on his computer, this is the one that basically is the piece of intelligence that connects Hamad Darzi to a particular hacker and to a server listening on a malware endpoint. But again, if you double click on any one of these pieces of evidence over here, it's going to come up and it's going to take that piece of evidence, it's going to pass it to the knowledge graph, and it's basically going to go and say, how is this piece of evidence related to everything else that we have in the knowledge graph? And it takes about 30 seconds for these things to run roughly. But what it's going to do is it's going to come back with how this piece of intelligence just connects to everything else. So instead of even typing in a question, you can just double click on a piece of intelligence and it tries to figure out how it fits in. So first it starts off and shows you the evidence, and then it talks about who's being mentioned in it. And because this piece of information is mentioning a server, it goes and looks up that server and it gives you the node reference for it, so you know this isn't being hallucinated. And you can look down, you can see what server it's coming from, what system it's running, what the malware endpoint is. All this is coming just from that one piece of intelligence. So this is very powerful. You can go in and really summarize key pieces of intelligence and how they connect to things. I'm going to go to the critical servers. This is the same thing. So you can click on any one of these. So this server here is 767676. This is a critical server that basically we're trying to find how this server could be affected by that piece of intelligence. So what you're doing is we're passing this server in, and it's looking up that server, and it's trying to see everything else in the graph that potentially is connected to that server, and making an assessment of what all that intelligence means when you look at it as a whole. So here's the server, and it's connecting a lot of stuff together here. It recognizes there's some basic information about the server, some technical specs, but here's where it really gets interesting. We can look in and we can see that because it looked at the graph and it knew that this server here was concerned because the server we're looking at was connected to this DMZ server, which is connecting to a malware endpoint. And there's a chance that this could be the server that's been affected. So they're saying basically, the AI is saying to isolate the server, and basically gives you some recommendations on what to do with it. This is true for the DMZ server. This one here is a good one to look at. Same with the malware endpoints. If you double click on a malware endpoint, this is really just a list of the malware endpoints we have, but what it's going to do is it's going to look at that malware endpoint and say, has this ever been mentioned anywhere, and is it connected to anything else in the system? Now, we have a lot of information about this piece of malware, which we'll see, and you'll see, some basic information about the malware, but the really interesting question isn't the malware itself, but how does that malware connect back up with the rest of the body of evidence of what's going on? So wait a few more seconds here. On this one, we'll return with an answer. Here we go. Highly sophisticated malware, SCADA water cooling systems, technical details, attack capabilities, vulnerabilities, infrastructure recommendations. So it really looks at that piece of malware and tries to figure out what potential things are interesting in that piece of malware. So we'll close that. Financial intelligence. These ones here, the double click doesn't do anything. It's just a list. I didn't think this would be interesting too much. And then the firewall logs that we have here. So from the cybersecurity side, things haven't changed too much, other than these double clicks. If you click on the Intel reasoner, I put a couple questions in here earlier. This works pretty well. So who's Hamad Darzi? This is really the best place to demo the power of the reasoner I'll just show you how to do it again. This Intel reasoner. So here's some questions I have in here. Who is Hamad Darzi? And this is showing some really good information about this one individual using a whole bunch of different information in the system. There's also a chlorine gas attack that's hidden in this information. So I said just explain the chlorine gas attack. And then it'll take that attack, break it down. It finds the core event, it finds the casualties. It looks at the pre-attack indicators. This is pretty interesting because it's able to connect this node 178, which is describing these chlorine gas tanks that were stolen. And then these guys here were trying to purchase some chlorine gas tanks later. They were released, load 198. Then talks about technical preparations, the groups potentially involved, post-attack analysis, why this is significant. And then one of the things that is interesting in here is one of these IP addresses, this one here, 148.27.07.030. If you look down here, I asked that same question, explain that server. And what it did is it actually pulled together the graph. It looked at that indeed that IP address was part of that malware attack, but it was also part of the chlorine gas attack. So it was able to find that, and it was able to link that and recognize that those two things might be connected. So that's a pretty cool thing to show. So if you really want to show the power of really reasoning over in a graph, use this reasoner here. It's quite powerful. If you just want a quick summary of a piece of information or a server, you're like, oh, what is this? Let's just pick this one here. suspicious. These are all, I made these things up. None of these are real. So let's take a ransomware attack on a manufacturing plant. So if you double click on that, it'll go in and run a query. You can see down here the query's running. There should be a box that's moving, but that's not showing up right now. So give it about 30 seconds and you will see the change here. So what it's saying here is I wasn't able to find that mentioned in the graph, because it isn't. There's nothing about this in the graph. But we do have information about it. So what it did is it took this information and it basically summarized it. So instead of reading this long line of like the table, the very boring table, it just makes it a lot easier to read. So that's basically what I wanted to show you. Thank you for watching this video about the review platform and the types of solutions that we can build with it. Please reach out to us at data2.ai if you have any questions. We're always happy to talk about use cases and how this can be applied to making your business or operations more efficient and intelligent.